All right, hello everyone. Welcome to our first slide video. This is going to be on markets and demand, and I kind of moved the flu shot shortages to the appendix, but you can check it out too. And I'll link to the old video where I talked about it a little bit more, but I think we'll be good with this. So this is for week 2, day 1. All right, so the reading that I want you to do in the edition 2 of our book is reading pages 9 through 14. So we're going to talk about supply or demand and markets today. Markets is basically the supply and demand model that helps us understand basic behavior of buyers and sellers. If you've seen the original or slides from week 1, we know that humans respond to incentives and businesses respond to incentives. So in the supply and demand model, price is our primary incentive. And what's nice about starting with supply and demand and markets is that they make intuitive predictions that are testable. And so we want to explore other models of behavior that build on supply and demand in this class. I want to think carefully about how assumptions affect predictions in the supply and demand model and how violating those assumptions can change the predictions. And then the other kind of objective is I'm going to more formally talk about the math and logical reasoning associated with supply and demand. So I'm going to assume that you've already had 201, and this is more of a review, but happy to talk about that more. So supply and demand, we're just looking to gain insight into why people trade, why prices are what they are, in kind of an abstract and flexible way. So people are buying things because it's making them better off. They demand the good, they want to buy it. So it's like you buying food at a grocery store, kind of. Sellers sell if the price is greater than the cost. So you supply the good, you sell your labor in a market. Is kind of the most common way you've been introduced to supply in the real world. And then, importantly, supply and demand does not require currency. So there can be a price without money. So think grade school lunchroom where food would be traded for food. In the real world, we have money just to help us facilitate transactions. So I had a friend who wanted to talk about abolishing the Federal Reserve sometime, and his dad was an electrician. I pointed out to him, it's easier for an electrician to buy video games for the kid if they don't have to pay GameStop and installed light bulbs. So a market is basically any and everywhere a transaction takes place. You can watch this YouTube video on a classroom market. And this experiment I do in my 201 class. And then there's also an economics article in which these markets are a good approximation for what happens and their predictions are useful. So supply and demand, it's built on assumptions, and we have to make these assumptions to make useful and intuitive predictions. There's many buyers, there's many sellers, homogeneous products, so everything is the same. Perfect information, rational buyers and sellers. So they make decisions in a careful enough way, and then you try to do things that maximize your well-being, whether you're a buyer or a seller. Um, these don't work for all markets, but some markets that they do work really well for are agricultural markets, where all apples are pretty much the same, and there's a lot of buyers of apples, and there's a lot of farmers, especially worldwide. And I'll just briefly mention some things about supply before I get into it in the slides for week 2, day 2. So the supply curve assumes sellers produce or sell more if prices rise. So we're investigating the effect of the change in a price on the quantity supplied. If and the predictions the supply makes is if the price of a good goes up, sellers will want to sell more of it. Um, and what we have here in this picture on the right is we're not showing any other variables that also affect supply uh, for ease of kind of exposition graphically. And we're going to build in more detailed models of supply as we go along. So basically what's going on in the picture on the right here is we have supply as price changes, assuming that other factors are constant that affect supply also. So let's get into demand a little bit more today. So it assumes buyers buy more if the price is lower and vice versa. So a more technical definition of rational profit preferences will be saved for unit 2 when we talk about constrained optimization. But for now, let's get more mathematically detailed about what a demand curve is. So we're modeling how much consumers demand of a particular good based on what the price is. And so um, formula for demand is quantity of demand equals some constant minus some slope term alpha times the price of the good. And so usually what we're going to have is in this kind of setup, alpha is going to be greater than zero. The price of a good is going to be non-negative, and the constant is greater than zero. So basically what that means is, non-negative price, alpha greater than zero is, a downward sloping demand curve or the law of demand, which I'll talk about. And then C is greater than zero. So if the price is zero, you consume at least some. And again, demand also depends on other factors, which are not modeled here, but we're going to consider, ceteris paribus or all else equal changes in price. And so this would be kind of a numerical example of a canonical demand curve where the constant is 20, C is 20, alpha is 1, and so then P is just, non-negative. So it ends kind of at 0. And basically what this means, right, is if, P is 0, then it's 20 minus 0, and this person demands 20. And if, price is 10, then it's 20 minus 1 times 10, or 10. So at price equals 10, they demand 20, or 10, sorry. And what's important to kind of keep in mind, and what I'm going to add to the math review on graphing, is this is an inverse demand curve, which is kind of weird how economics developed this. But uh, anyway, what happens is normally we think of price determines what quantity demanded is. So usually price would be on the x-axis, but in economics we have it the other way around. And so it's something to keep in mind, especially when you do homework 1 and I ask you about what the demand curve equation is. So I want to talk a little bit more about the law of demand with a very simple example. So let's consider a point on a demand curve, call it D1. And what we have is at price equals 10, this individual or in this market, 10 units are demanded, right? And so the law of demand just says that as prices increase, the quantity demanded decreases. So as prices go up, you buy less because you can use that money for other things. And so you can't just buy an unlimited amount. And so as the price increases, you buy less. Well, all right. So let's see what happens if the price goes down. And so we know that if the price is less than 10, that's all these potential demand points in this gray box here, right? And so we want to think about if the price goes down from 10 to 8 or 10 to 4, what's going to happen to the quantity demanded? So are we going to come down here and go over to the left or go over to the right? Well, if we consider price less than 10, quantity less than 10, that's this new gray box here. And what we know from the law of demand is that there's going to be uh, less than 10 units demanded if, uh, if the price goes below 10, then the law of demand states that the quantity can't go below 10 because we know the law of demand says as prices decrease, demand increases. And so we know that there's going to be no demand points in this box given that this is a point and the law of demand is satisfied. This would only make sense for very specific luxury goods. So what we can say is that when the price is less than 10 and when the price is 10 and quantity demanded is 10, then if the price goes below 10, then the quantity demanded will be greater than 10. So these are all points out here that would be consistent with the law of demand. And you can, if you're having trouble with the red and the greens, I'm sorry about that. There is a colorblind friendly image in the appendix. And so conversely, we know that if the price goes above 10, that the people are going to demand less. So anything in this green box is possible. And if the price goes above 10, then uh, any of these points are not possible because that would mean that the price is increasing and we demand more, which is not consistent with the law of demand. Okay, so we know that the quantity demanded depends on price. Here's some other determinants of demand that are not shown on an axis in the graphs that I showed you, but are working in the background. And changes in these things don't cause a movement along the demand curve, but they cause the entire demand curve to shift. And so one of those things is income or wealth. The amount of money you have influences your demand curve. And so if the good is normal and your income goes up, uh, ooh, that's a typo. It shouldn't be QD up. It should be uh, demand up. So no Q's, just a large D. Basically, if a good is normal and you get more money, your demand curve will shift out. And so for an inferior good like hot dogs or ramen noodles, um, your as your income increases, your demand for them decreases. Okay, another determinant of demand is your preferences. So, how much you value the consumption of a good or a service matters for how much you demand of a good. And this is encoded into utility, which approximately means happiness functions. And what we do is we make assumptions about your happiness and how it changes with the amount you consume when we write down a utility function. So we have to consider some things like a realistic assumption to consider is diminishing marginal utility. So as you consume more of something, each additional unit gives you less and less happiness, additional happiness. And so some utility functions where that is consistent is a square root of a good, which can be written in several ways here, or the natural log of a good, or we can also have utility that depends on multiple goods, like uh, you know, 3 times the square root of apple plus 2 times the square root of the number of oranges plus 1 times the square root of bananas. And so basically, what this picture says here is that you prefer apples to oranges to bananas. And if you have a dog, you could say that their utility depends on how many pets they get and how many treats they get. And for most dogs I know, um, treats are more valuable than pets. So anyway, prices of related goods are another thing that happens. So these would be encoded into utility or demand functions, and demand depends on the prices of related goods and vice versa. So for price decreases, anyway, so if you have a substitute good and the price of the substitute good increases, then the quantity demanded of a good will increase. So um, if the price of Coca-Cola goes up, and then the quantity demanded or the demand for uh, Pepsi will go up because Coke and Pepsi are substitute goods. They're close enough to similar that if the price of one goes up, you'll substitute into buying the other. And then the other thing is complementary goods. And so peanut butter and jelly would be examples of complements. If the price of a complementary good goes up, then your quantity demanded of a specific good goes down, or just your demand goes down. Man, I have a lot of typos in these. And so what this basically means is if the price of peanut butter goes up and you like to consume peanut butter with jelly, then your demand for jelly will decrease if the price of peanut butter increases. Expectations, and the last thing, I won't talk about it too much, but how you expect the market to change in the future determines your demand now. And then another one that is intuitive is the number of buyers in a market also affects the demand of a market. So um, in Morgantown, where WVU is in the summertime, uh, there's no students, and so the demand curve is something. And then when the students come back, the demand for goods in Morgantown shifts out because there are more buyers in town. Um, the one last thing that's really well, not one last thing, but one thing that's really important is we use quantity demanded to refer to a specific point on the demand curve. And demand, not with quantity in front of it, refers to the entire curve. And so that's kind of where my typos were. And so in this example, a point on the demand curve is so the entire demand curve is shown here. This is demand, and it's 20 minus 1p. And so we can have at price 3, quantity demanded equals 17. And so say the seller of the good decides to increase the price. If the price is raised too high, then no one will buy the product or go to the competitors. So if the price of this good goes above 20, then the quantity demanded will be 0 or less than that. And so you saw this in the first week of slides. This vertical line is conditional on or if. And so market equilibrium is something else that we're going to talk about in the upcoming videos. It's where the price moves towards in response to buyer and seller interaction in the absence of government intervention. And in a competitive market, where supply and demand meet is the most efficient outcome, and it maximizes social welfare. If you want to see how this happens in person, you can look at this lab experiment. So I want to give you a couple examples of uh, how we would analyze changes using the supply and demand framework. So some background is good fireworks, ones that go up in the air and go boom, became legal in West Virginia kind of last minute in 2016, and I signed up to manage a tent. So let's assume that there's perfect competition in the market for firework tents. And so here's our supply and demand framework. Let's think through a scenario. The first scenario that happens is more tents in years after 2016. So what is going to happen in our market? Well, we know that an increase in the number of buyers leads to a shift out in demand. Well, this is an increase in the number of fireworks tent sellers. And so this light blue curve was our original supply. And after more tents moved into the area, this would be our supply afterwards. Okay. And I'll call this supply, prime, or this little apostrophe a lot of the time. Okay, so let's go back to our original supply and demand market and consider a different shock to the market. Let's say that a stimulus check is sent out, and let's pretend that it's not in response to some other bad thing. So stimulus check, ceteris paribus. What happens to our market? Well, what happens is income is a determinant of demand. And so, in response to a stimulus check, the demand curve shifts out from this navy curve to this gray curve because people have more income and thus their demand for fireworks shifts out. Um, I hope these scenarios look familiar. You're going to see them on your homework for Unit 1. And I hope to help you through anything I can for these. Anyway, the conclusion is supply and demand is a flexible model for making predictions in many scenarios. Quantity demanded depends on price, and the actual demand curve itself depends on several other factors. Supply and demand can be used for insights into fireworks and flu shots and a ton of different things, which we're going to develop throughout Unit 1. And that's all I have for today. There's a lot of appendix materials, such as the colorblind friendly and stuff about the flu shots that I thought was a little much for the first video, but happy to talk about it if you need me to. And I'll see you next set of slides for 2.2. Thank you.